بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. This is Major 1 Calculus 1 Term 221. Let us have a look to the major and try to solve it together. So the first question, a graph is given and certain questions are asked. First, find the limit of the function when x approaches 3 from the left. Well, this is x, the x-axis, the values of x are here, and we need x to approach 3. This is the number 3, x equals to 3, and we need to approach 3 from the left. So we go from the left until we approach this number 3, and we look to the curve. What happens to the curve? The curve is going to negative infinity, so that's the limit of f of x when x approaches 3 from the left. The second question, find the limit when x approaches 2, the limit of the function when x approaches 2. So this case, I'll concentrate on 2, and I need to find the limit when x approaches 2. Well, x can approach 2 either from the right, and in this case, the function will approach this number, which is 2, or from the left, and in this case, the function also will decrease to this number, which is 2, so the limit is 2. So this how do you find the limit, okay? For example, if you want to find the limit when f of x approaches 3 from the right, okay, this is 3 from the right, it will approach what? 4, okay? So the limit of f of x at 3 does not exist because from the right is not equal to from the left. This is just to illustrate to you how to find the limits. All right. The x values at which f is not continuous. So we need the values, the x values, at which the function is not continuous. Well, the function is not continuous when there is a discontinuity in the graph, okay? Also, when the limit of f of x as x approaches a equals f of a, if this happens, then the function is continuous at a. But if f is not defined at a, then it's not continuous. If this limit does not exist, then the function is not continuous. If the limit exists and the function is defined at a, but they are not equal, also the function is not continuous. So you can see that at 2 here, we have a hole. So the function is not continuous at 2 because it is not defined at 2. At 3, the function is defined. There is a closed circle here. So f of 3 is 4. But the limit from the right of 3 is not equal to the limit from the left of 3. So the limit does not exist at 3. So the function is not continuous. And you can see that there is a gap, a big gap here. Also at 5, the function is not continuous. There is a big gap. The limit does not exist because the limit from the left equals to 2, while the limit from the right equals to negative 3. At 6, the function is not continuous because it's not defined. The function is not defined at 6. So at these numbers, 2, 3, 5, 6, the function is not continuous. So this is the correct answer. What is f of 3? As we mentioned, this is 3, go up. F of 3 would be at this closed circle, which is 4. So f of 3 is 4. List all the vertical asymptotes. What is the definition of the vertical asymptotes? Well, the definition, if you find the limit when x approaches a of the function, and you find that the answer is a number over 0. In this case, the result would be plus or minus infinity. So if the limit is plus or minus infinity, or when you have it algebraically defined and you have a over 0, this means x equals to a is a vertical asymptote. Look here for this line, x equals to 3. Okay, what is the limit when x approaches 3 from the left? You have seen that it is negative infinity. So because the limit when x approaches 3 from the left is negative infinity, x equals to 3 is a vertical asymptote. Also, what x equals to 6, this line. Why? Because the limit when x approaches 6 from the right or from the left is what? Is infinity. So there are two vertical asymptotes, x equals to 3 and x equals to 6, and that's the correct answer. F of x is not continuous at x equals to 3. Why? We mentioned because the limit does not exist. Because the limit from the right is not equal to the limit from the left at 3. So the limit does not exist. Of course, f is not defined. This is not correct because f of 3 is defined and it's equal to 4, as we have seen in question 4. 3 is not in the domain. That's not correct because f of 3 is defined, so it is in the domain and it's equal to 4. Second question, a piecewise function is given and we need to find the limit when x approaches 0. Well, the function changes, the definition changes at 0. If x is greater than 0, there is a definition. If x is less than 0, there is another definition. So to find the limit of the function when x approaches 0, we have to find the limit from the right and the limit from the left. So limit from the right of 0. In this case, what would be the definition? We are approaching 0 from the right. So we are dealing with numbers greater than 0. So this would be the definition, x is greater than 0. So the definition is 8 over x plus 4 plus 3x. Now, to find the limit, I replace x by 0. 8 over 0 plus 4 means 8 over 4, which is 2. 3 times 0 is 0, so the limit is 2. What about the limit when x approaches 0 from the left? When I approach 0 from the left, I have to use this definition because x is less than 0, because we will deal with numbers less than 0. So the definition is 2 times ex plus sine x, and I need to find the limits of this function when x approaches 0 from the left. So I replace x by 0. 2 times e to the power 0. E to the power 0 is 1. 2 times 1 is 2. Sine 0 is 0. So the answer is 2. The limit from the right equals to the limit from the left. So the limit exists and it is equal to 2. The limit when x approaches 4 from the left. Okay. Does the definition changes at 4? Yeah, this is 4 here. And less than 4, there is a definition. Greater than 4, there is another definition. So which one? We are approaching 4 from where? From the left. From the left, so we need numbers less than 4. So we deal with this definition. So the limit would be limit, and f of x will be here 8 over x plus 4 plus 3x. To find this limit, we replace x by 4. 4 plus 4 is 8. 8 over 8 is 1. 3 times 4 is 12. So the answer is 13. The limit is 13. Now we have two functions, f of x, g of x, and we need to find their composition. Well, the method is to change the circle to parentheses. That's the first step. And then we write the definition of the inside function, which is f of x. So we say that this is equal to g of f of x. But what is f of x? This is f of x. So we write it here inside g. And now we find g of this. Well, I need the definition of g of x. That's the definition. What happened? I can find, this is the definition of g of x. Well, he replaced x. This x is replaced by this one, f of x. So I need to write the right-hand side and replace x also by the same function. So the answer would be len 5 times, instead of x, I write negative 2x plus square root of x. This is always how we find g of something. G of 1, for example, would be len 5 times 1. G of anything would be len 5 anything. So this would be the case. And now if we multiply 5, okay, distribute 5, 5 times negative 2, that's negative 10, and 5 times square root of x. So we search for this answer. It is this one, C, negative 10x plus 5. So that's the answer. What are the vertical asymptotes of this function? The definition of the vertical asymptote, the limit when x approaches the number has to be infinity or negative infinity. So you can check, and it should be a over 0. You can check, for example, the limit when x approaches 4 for this function f of x. What would happen? Replace by 4, 16 plus 24, that's 40. Here, 16 minus 4, 12 minus 12, 0. You have 40 over 0, so it's plus or negative infinity. So x equals to 4 is a vertical asymptote. You can also check negative 3, 3, negative 4, okay? But also, there is another way. We factor, if you factor this function, factor the denominator, take x as a common factor, and these three terms can be factored into x minus 4 times x plus 3. Now, what are the zeros of the denominator? The zeros of the denominator, either x minus 4 is 0, so x equals to 4, or x plus 3 is 0, so x equals to negative 3. These are the zeros of the denominator. Are these zeros of the numerator? No. So they are vertical asymptotes, and this is the correct answer. But if 4 is a zero of the numerator and the denominator at the same time, then it is not a vertical asymptote because the limit will not be number over 0, it will be 0 over 0. So the vertical asymptote has to be a zero of the denominator only, not the numerator. The domain of this function, well, I have square root of 7 minus x. So I know that in the square, whenever I have a square root, what is inside the square root has to be greater than or equal to 0. But since the square root is in the denominator, so it cannot be equal to 0. So 7 minus x cannot be equal to 0, and I have to remove the equality sign here. Solving this inequality, if you take 7 to the other side and then multiply by negative 1, and because of that you need to change the direction of the inequality, the answer is x less than 7. So if this is 7, this is the answer, less than 7. So it's from negative infinity to 7, and 7 is open because there is no equality here. So the correct answer is this one, from negative infinity to 7. Find the limit when x approaches 4 from the right. All right, if I replace x by 4, it would be square root of 4, which is 2, plus 3 times 4, that's 12, over 4 minus 4, which is 0. So I have a number over 0. This means that the line x equals to 4 is a vertical asymptote. And also, it means that the limit would be either positive or negative infinity. 14 over 0, either positive or negative infinity. How to find out which one of them? Okay, we are approaching x from where? From the right. From the right. So we deal with numbers greater than 4. So choose a number greater than 4, choose a number that's close to 4. So for example, 4.1 will work. Replace x in this quantity by 4.1 to check whether this quantity is positive or negative, okay? So square root of 4.1 plus 3 times 4.1 over 4.1 minus 4, that's 0.1, Okay, is this positive or negative? The numerator is positive. The denominator 4.1 is greater than 4, so it's positive. So the answer is positive infinity and not negative infinity. Is this function odd, even, or neither? To find out, we evaluate f of negative x. Well, f of negative x, where to find it, see what happened. This x is replaced by negative x in the left-hand side. So you go to the right-hand side and replace each x there by negative x. And do not forget parentheses, because the power is a power of negative x, all of it. Now, what is negative x to the power 2? Negative 1 to the power 2 is positive. So also to the power 4, when you raise negative 1 to an even power, you get a positive number. So negative x to the power 2, negative x all to the power 2 is actually x squared. Also negative x all to the power 4 is x to the power 4. And now you look to this function, to the result. Is it equal to the original function f of x? And yes, in this case, yes. So the function immediately you say, this function is even. But if it is not equal, if they are not equal, you find negative f of x. You multiply f of x by a negative number, negative sign. And if you find that these two are equal, then the function would be odd. If they are not equal, you say that the function is neither. So there are three cases. Either if negative x equals f of x, in this case, the function is even, or f of negative x equals negative f of x, the function would be odd. If nothing, if neither of these two, then the function is neither. Find this limit. Okay, replace x by 4. So 2 minus square root of 4, 2 minus 2, that's 0. 4 minus 4, 0. I have 0 over 0. Whenever you have 0 over 0, you try something algebraic. So you simplify, either by factoring, or maybe multiplying by the conjugate, or maybe other types of simplifying. So here, can I factor? Which one of these can be factored? In fact, we know that a square minus b square can be written as a minus b times a plus b. This is called difference of two squares formula. So 4 minus x, this 4 minus x in the denominator, I can write it 2 square minus square root of x to the power 2, because square root of x to the power 2 will give you x. So using this formula, I can write it 2 minus square root of x times 2 plus square root of x. So here I can solve this equation by factoring. I can say this is the limit x approaches 4, 2 minus square root of x, I keep it, and I factor the denominator into 2 minus square root of x times 2 plus square root of x. So I can cancel these two, and now I have 1 in the numerator, and in the denominator I have 2 plus square root of x. If I replace x by 4 to find the limit, I'll have 2 plus the square root of 4, which is 2. 2 plus 2 is 4, so that's the answer. Of course, if you want, you can solve by multiplying by the conjugate. So you can, after you replace x by 4 and you find 0 over 0, and you have square root in the 2 minus square root of x in the numerator, so you may think of multiplying by the conjugate. And the conjugate of two terms, the same two terms, but you change the sign in the middle, only the sign in the middle. And when you multiply these two fractions, you multiply the numerators. So 2 minus x times 2 plus square root of x, these two will give you, as you can see here, 4 minus x. And in the denominator, you will have 4 minus x multiplied by 2 plus square root of x. These two will be cancelled. You still have 1 in the numerator, and in the denominator, when you replace x by 4, 2 plus 2 is 4, so that's the answer. Finding this limit, well, I have an absolute value. and the absolute value is a piecewise function because absolute value of x is either x or negative x. It is x if x is positive, and it's negative x if x is negative. So if we have, let us call this function f of x, for example. Okay, so if when we have absolute value of x minus 4 using the same definition, okay, I replace each x by x minus 4. So here I'll have x minus 4, here negative x minus 4, and here x minus 4 is greater than or equal to 0, and here x minus 4 is less than 0. But solving this inequality, I can take 4 to the other side. So I will have the definition. This would be when x is greater than or equal to 4, and here when x is less than 4. So this is the definition of the absolute value. So you have to go from the right and from the left. So let us approach 4 from the right. In this case, there is no change in the numerator. But when I approach 4 from the right, x would be greater than 4, and I have to deal with this definition. So absolute value of x minus 4 would be equal to x minus 4. And now if I replace x by 4, 16 minus 4 minus 12, that's 0. And 4 minus 4 is also 0. So let us try factoring. Factor the numerator. It's a trinomial. Two numbers, their product is negative 12. Their sum is negative 1. They are negative 4 and 3. I can cancel these two and replace x by 4. 4 plus 3 is 7. So that's the limit when x approaches 4 from the right. What would be the limit when x approaches 4 from the left? Well, x squared minus x minus 12 as it is. And now x approaches 4 from the left, so x less than 4. So the definition of absolute value minus 4 would be negative x minus 4. When you replace x by 4 again, you get 0 over 0. So you try factoring. And the same as above, but I'll have a negative sign here. So when I replace x by 4, I'll have 7 up in the numerator, but in the denominator, I still have negative 1. So the answer is negative 7. So what is the conclusion? The limit when x approaches 4, limit of f of x from the right is not equal to the limit of f of x when x approaches 4 from the left. So this means that the limit of f of x when x approaches 4 does not exist. Well, to find this limit, as usual, I replace x by 0. So I'll have e to the power 4 times x, that's 0, plus 5 times cosine 0, which is 1. So the answer is e to the power square root of 5. Here I replace x by 7. 49 minus 49, that's 0. 7 over 7, that's 0. Let us try factoring. Notice that 49 is 7 squared. So I have x squared minus 7 squared. So I can factor it into x minus 7 times x plus 7 over x minus 7. Cancel these two, replace x by 7. 7 plus 7 is 14, and that's the limit. Use the squeeze theorem to show that the limit of this x squared cosine is 0. So squeeze theorem says that if you have a function f of x and you can put it between other two functions, for example, g of x and h of x, and if the limit of g and the limit of x of h when x approaches a number, okay, is, for example, 0 or any limit, a, for example, okay? And this is a, then the limit of the function in the middle also has to go to a. So here I have cosine 5 over x. I know that cosine is always between -1 and 1. This is from geometry. So, but the function x squared times cosine. So if I multiply the inequality by x squared is positive. So no problem to multiply by x squared because the directions of the inequality will not change. So this would be the new inequality. 1 times x squared is x squared, -1 times x squared is negative x squared, and I have x squared cosine 5 over x in the middle. And this is my function in which I need to put it between two other functions. Now he is asking about the limit when x approaches 0. So I have to check that the limit of negative, what is the limit of negative x squared when x approaches 0? And what is the limit of x squared when x approaches 0? This one and this one. Well, in both cases, when I replace x by 0, I get 0. So the limit of both of them is 0. So by squeeze theorem, I'll have the limit of the function in the middle, which is cosine x squared cosine 5 over x. This also, the limit would be 0 when x approaches 0. That's the squeeze theorem. Here, find the inverse of the function. To find the inverse, I replace f of x by y. That's the first step. Then the second step, I solve this equation for x. And to solve it for x, I will cross product, use cross product. So this is y over 1. So y times 1 plus 2ex equals 3 times 1, which is 3. Now I need to solve it for x, so I don't need this y. So take it to the other side. How? You divide because this is product y multiplied by. So divide by y. So I will have 1 plus 2 e to the power x equals 3 over y. Then this one also is not needed because I need to solve for x. Take it to the other side. But how? By subtracting -1 because it is added to 2 plus 2ex. So the answer would be -1 plus 3 over y. And now how to get rid of this 2? Divide by 2. Okay, so or multiply by half. So 2 will appear in the denominator in the right hand side. Now I need to solve for x still. So I need x, not ex. So apply len to both sides to get rid of e. So when we apply len to both sides, we know that len ex is x. They cancel each other because they are inverses of each other. So we solved the equation for x. X is in fact equal to len -1/2 plus 3 over 2y. The next step, interchange y and x. Call x, replace x by y, and replace y by x. And the final step would be change y to f inverse of x. So that's the answer. F inverse of x is len -1/2 plus 3 over 2x. That's the answer. If you want to add these two fractions, it's okay. If you keep it like this, it's okay. To add them, I will multiply up and down by x. I have -x over 2x plus 3 over 2x. So I'll have same denominator, 2x, and I add the numerators, -x plus 3. So this also a correct answer. Both are correct. This is the inverse function. The last question is about continuity. Find the value of c so that f of t is continuous at t equals 3. The function would be continuous when the limit of f of t as t approaches 3 equals to f of 3. In fact, f of 3 here because t here greater than or equal to 3. To find f of 3, we use the second definition. We replace t by 3. So it would be square root of 3 squared, which is 9 plus c. This is f of 3. But I need to make sure that the limit exists. Well, the definition changes at 3. So I need to find the limit when t approaches 3 from the right and from the left. From the right, I need numbers greater than 3. So again, I'll use the second definition. So t squared plus c. Replacing x by 3, I will have square root of 9 plus c. And you notice that this is f of 3. So in fact, the function is continuous from the right. But this is irrelevant. He didn't ask about it. Uh, but it is not continuous from the left. Okay. So to find the limit from the left, I'll use numbers less than 3. So I have to use this definition. So 8 minus t would be my function. Replacing t by 3, 8 minus 3 would be 5. Now, the limit exists. The limit exists when if the limit from the right equals to the limit from the left. So if square root of 9 plus c, which is the limit from the right, equals to 5, which is the limit from the left, then we need to find the value of c. Square both sides. Take 9 to the other side. C would be 25 minus 9, which is 16. So if c is 16, then the limit exists and it would be equal to f of 3. So the function would be continuous at 3. So that's the solution. That's the end of this major. Notice that this major, the questions in this major are up to section 2.5. So if your major has other sections 2.6, 2.7, 2.8, you have to review something else. I stop here. Thank you very much and see you in other on other videos, inshallah.